All right, number 7 says suppose we want to travel d miles at a constant speed of 6 plus x miles per hour, where x could be a positive or negative integer. The time in minutes required to travel d miles is t of x, which is equal to 60d times the quantity 6 plus x to the negative first power. We're going to show that linear approximation to t at the point x equals 0 is equal to t of x, which is approximately Lx, and then we have our formula. So let me make a connection really quick. When we're doing linear approximation, it's pretty much the same as point slope formula that we're used to from algebra. Okay. If we add this y value over, so we'll have a y equals y1, and then it'll be plus m x minus x1. This is the formula we're using. They're just changing the variables. This y is now Lx for linear approximation. This is what we're calling our f of x. Our slope, we know we get from the derivative using calculus, f of x prime. And then it is times x minus a. So this is, or x line, yeah. This is a formula that we show for linear approximation. So we're using this t of x formula, and we're going to apply this same process. T of x is equal to 60 d. D is going to be a constant, so we're not treating it as a variable. 6 plus x to the negative first power. All right, we're going to do this in 4 steps. First, we want to find t prime. So just take the derivative. The only variable, which is we're doing in terms of x, we're going to use the product rule, so multiply times a -1. So this will be a negative 60d. Leave the inside alone using the chain rule. And then subtract 1. So it'll be a -2. And then the derivative of the inside, that'll be 0 plus 1, which is just times 1. So here's our derivative for part 1. I do not believe that it's case sensitive. All right, part 2, it says substitute A into Lx, choose the correct response. So again, writing this formula out with what we have, Lx equal to our Tx formula, which is here, but it says plug in A. So this will be 60 times D, 6 plus 0. That is f of a, and then we're going to do plus the slope. The slope is the derivative, plugging in 0. So this will be a negative 60d, 6 plus x, negative second, times the x minus a, which will be x minus 0. So that's what we're looking for. Plus negative, it's missing the x minus 0 factor. This one looks good. Double check. Has a minus minus. We have a plus and then a minus. And then this one just has a plus. So B looks best as far as plugging into our formula. Sorry. Keep wanting to hit next. All right, part 3, it says, rewrite L of x with positive exponents and reduce to lowest terms. It says, do not factor. Okay, so we're going to simplify this. This is 6 plus 0. And then 1 to the negative power, we're going to move that to the bottom. So this is going to be 60d, and then divided by 6. And then I'll just go ahead and write minus. And then x times 0 is just going to be x. So I'm going to have an x as a factor. This will be 60d. Now I don't know why I wrote an x. This should be 0 because we plugged in a 0. So this will be 6 squared, but it's going to be on the bottom. And then times x. All right, the one more thing I can do to simplify is I can divide top and bottom by 6, and so that will leave me with 10d. And I can divide top and bottom here by, just get rid of a 6. This will be 10d over 6 times x. All right, so this is simplified without factoring. I'll probably simplify that a little bit more. 5 over 3. But I'll leave it, I think, in that form. Okay, they don't like it. Though your answer is equal to the correct answer, it's not in the correct form. All right, so I'm going to reduce this, and this will be 5 over 3. Maybe that's what we want to do. All right. Let me write 5 over 3. All right, and then part 4, it says factor out the common factor, and then we'll write the function. So here, we can factor out a 5d. So pull out 5d. When you divide by 5, this will be 2. This will leave us with minus 1 over 3x, or x over 3. And that'll be it. I believe that's what they wanted us to prove at the very beginning. 2 minus x over 3. I just got the x to the side, 5d. So we're just verifying that this is the linear approximation function, 5d, 2 minus 1 over 3.